All right. What is up, everybody? We're doing another 0 1 knapsack problem now. I don't know what else there is to say, so let's get into it. Given a set of positive numbers, partition the set into two subsets with minimum difference between their subset sums. So example one, we have 1, 2, 3, 9. Output's 3 because we can partition it into 1, 2, 3, and 9, and the minimum absolute distance will be 3. Um, that's very important because um, we want to. Okay, and I guess another thing is there's this other problem called what is it? Minimum subset sum difference. And there's this one question, partition array into two arrays to minimize sum difference. This is a very different problem, even though the title is very similar. Um, for that problem, regardless of what happens, you have to make each array the same size. Whereas in this problem, um, you can have literally whatever you can have every number in one subset and one number in the other subset, as you can see here. Um, so yeah, hopefully you don't get confused. Um, I know the naming can be a little bit confusing, but you know, um, yeah, that's that. So, I guess without further ado, let's just get into solving the problem. Let me change this to nums, actually. I don't like num. So basically, we're going to have a variable n for the length of nums, right? Because we're going to be using the length of nums, actually only a decent amount, but I mean it probably would justify it, right? And then we're gonna put goal sum is equal to the um let's see if I want to actually do that. Yeah. So actually no, we'll just do s for sum of numbers. And so because we're going to be using this variable a little bit, we're going to create a 2D array again. It's going to be a true or false one this time for columns in range of. So now this is the part that's a little bit tricky about this problem. We want an integer s divided by 2 plus 1, and then we want to create the number of rows in the range of n. So the reason why we want to do the sum divided by 2 plus 1 is because we want to get as close as we can to the middle of like the sum, right? Because if we can create the sum divided by 2, that means we can create a difference of 0, right? And the reason why we want a plus 1 is because we want to include the 0 as well, so 0 all the way until this number. And we do int of s divided by 2 because that will round for us if it deems it necessary to round. So yeah, we're going to do a few of our base cases for I in range of n. We're going to do dp of I 0 is equal to true. Because regardless of what number we use, we can always create the sum of 0 for j in range of int s divided by 2 plus 1. Let me put some spaces here. Close off the thing again. And so now for the first column, so dp0 j, dp0j will be equal to true only if num0 is equal to j. Because with one number in our subset, that's the only way we can create that's the only one number we can create for the sum using that one number, right? Because if it's one number, that's the only sum you can create. So now you want to process all of the possible sums that you can create using the subset. So we're going to do for I in range of 1 to n, and then for j in range from 1 to int s divided by 2 plus 1. We're going to, if dp of I minus 1 j, if that's true, then we can just set dp of I of j is equal to dp of I minus 1 j. Or you could honestly just do is equal to true as well, because the check is if it's true, then we come in here, right? So but then we're gonna do an else if j is greater than or equal to nums I, then that means we haven't set this equal to true yet, so we can do this other calculation. dp of ij is equal to dp of I minus 1 j minus nums I. It's like the same pattern as before. So basically, if we can create the sum of all the numbers, like, so let's just say we're looking at for this, our middle will be 9, 12, 15 divided by 2, 7.5. So I think that rounds down to 7, and then divided by 2. No, 7 and then plus 1 because we want 0 through 7. So it's 7. We will, what do you call it? So I guess if we go, yeah, let's just go with 7, and we have the subset of like 1, 2, and 3. Actually, we'll do 6 because it's easier to calculate it that way. So if we can do 6, and then we're at the 3, right? Because that's like our order. So 6 minus 3 is 3, and we can check the row above for like the smaller subset. And since we can make 3, then that means we can also make this sum because our current number that we're looking at is 3, right? I hope that made sense. And so now we need to get our two sums. So our first sum and second sum, we're going to both set them equal to 0 for now. And so for I in range of int s divided by 2, we're not going to do plus 1 this time because we're doing this in a for loop, right? So we can't actually do, we don't actually have this plus 1 index, we only have this index. So from here, if dp of n minus 1, because n would be too far, we don't actually have n, we have 0 through n minus 1, so you need to do n minus 1 here. Whoopsies. Our first sum will be equal to I. The reason why it's equal to I is because we're saying from our calculations we can create this index. We can create this sum at whatever index we're currently at for the column. So that means we can create this sum and we'll break out. And then so our second sum will be equal to our total sum minus first sum, right? Because that just means with whatever numbers we've used to create first sum, sum minus first sum will grant us second sum, because any number not used in first sum will just create second sum, right? So if we take the total sum minus whatever numbers we've used, then that would leave us with second sum. And then so we want to return the absolute value of second sum minus first sum, right? And so let's create some expected values here. We expect 3 because 9 minus 6 will be 3. Here you can do how would you do this? oh, this can actually be 0 because 5 plus 2 creates 7, right? Okay, let me actually just write it at the very bottom. 1, 2, 7, 1, 5. So then we can create our first set of 2 and 5 and 7. 2 and 5 and 7. So we leave each one with a 1. So we can actually create a sum of 8, and that will cancel out to 0. And here with a 100, it's kind of easy for us, at least as humans, to see it. This would just be 92 because 100 is the largest, so you try to add everything else together to try to bring down the difference as much as possible, which will give you 92. So if we were to run this code, run Python file, we get 3, 0, and 92. So yeah, that's how you will do this minimum subset sum difference problem. Yeah, so with that being said, thanks for watching.